Hey YouTube, this is Jaren again. As promised, I was going to show you what schematics look like today, how to identify basic components on a schematic, and basically what schematics show you. So a schematic is essentially a layout of components and how they connect with one another. They don't necessarily have to be laid out this way physically when you do your project, but they just help you show where connections are made and they help other people troubleshoot your work. If you don't make schematics, I can almost guarantee you will get lost at some point. So please pay attention to what I'm saying, and if not to what I'm saying, go look it up online and try to make the connections to what I'm going to say now. So in order to understand a schematic, you need to know what the most basic circuit entitles. So the simplest possible circuit has three components to it: a source, a conductor, and a load. The source provides the power that the load uses to do work. I'll explain all those words later and what they mean. But all that the conductor does is essentially connect the power from the source to the load in order for it to do its work. The conductor also, in this case, is what I'm showing, is the lines that are between components. So don't be confused by all the lines that you see on a schematic, because they're just, again, simply denoting what components are connected to what and how they are connected. The next couple of things that I'm about to show you are actually going to be a really simple circuit, and I hope you can follow along. But before we go any farther, I'm going to show you the schematic symbols that I used. The schematic symbols of the components that I used in this circuit so you can follow along. If you need to, pause and absorb, because I will be using these symbols a lot more in later videos. So you're never going to see an okay, that's false. You're unlikely to find any electronic circuits that do not have resistors in them. Resistors are these small cylindrical objects that typically come in quarter watt, half watt, 1 watt, and other all over the state's rating. But you need to be careful of them, and pictured in the top left hand corner is the bit that you need to remember for now, which is their schematic symbols. Okay, the next thing that I need to show you is an LED. This will be what we're using in a circuit too, because I don't actually have, Ella, can you come here? I don't actually have any incandescent bulbs with me, so I'm going to have to use an LED, and that's what the resistor for, is to protect it. And I'll go into more detail with that later, but just for now, follow the schematic that I show you later. Memorize the symbols to the top left, and I'll explain what the other one is, but those will be important for this next bit. So the next schematic symbol I'm going to show you is either going to be a cell or a battery. There is a difference between a cell and a battery that nobody seems to pick up on very easily, and the difference is a cell is a single cell. A battery is a collection of cells wired together in some form or another. So cell, battery, remember that. Top left corner is the schematic symbol for a battery. Top left corner is the schematic symbol for a cell. Again, if you need to go back through and pause the screen to absorb these, please do, because I'm going to jump right into this next part. My sister's going to take the camera, and I'm going to show you a little schematic, and pause the screen and see if you can wire this circuit on your own. If you don't have components yet, because you're waiting for me to give you a list of components, then just see if you can get the gist of what I have to do. So I'm going to hand my camera off to my sister, and then I'm going to show you the parts that you need for this. Got it all? Mm-hmm. Okay, so the parts that you're going to need for this, for people that are a little more experienced, you'll recognize this as a 220 ohm resistor. Can you get closer to that? Maybe they can see the bands. Okay, well anyways, a 220 ohm is a red-brown color coding on it. The next thing you're going to need is 3 conductors. I don't care if it's alligator clips, wire, or anything that you can just simply get a connection from this battery to go around the circuit. The next thing you're going to need is an LED, which is right here. Now, this little next bit is going to be important because, again, it's not an incandescent bulb. An LED has 2 leads. I'll tell you what they mean later, but for now, all that you need to know is the longer side. The longer side is actually the arrow pointing into the line. So that's the positive side, and the shorter side is the negative side, which goes towards the more negative side of the circuit. So go ahead and pause the screen, look at the schematic, and then you see if you can see what I'm about to do with these wires. Okay, so here we go. Color doesn't matter for right now, but it will later, and I'll show you why. But according to the schematic, all that we're going to do is we're going to connect the positive side of the battery to the positive side of the LED. And then we're going to connect the negative side of the LED to the resistor according to the schematic. And then from here, we're going to connect the resistor to ground. And apparently that's not the longer lead. Just give me a moment. When you do find the longer lead, you get light, like so. So again, source, loads, both the resistor and the LED, and then everything connecting everything is called the conductors. So again, in the schematic, we go from the positive side of the battery to the positive side of the LED, through the resistor, and then back to ground. You can even move the resistor to either side of the circuit and it'll work, but that's for you to experiment with. Go ahead and see what you can do, and I'm going to continue on with the rest of the video. Thank you, Ella. Okay, so now that you know the basic parts that we're going to show you, as we go farther and farther on, you're going to see connections start crossing one another. So if you see a dot at where they cross, it means they're connected. If not, then don't bother connecting them. Okay, so a couple of components that we're likely to run in throughout this, and I'll explain them as we go, are these capacitors. Just pause and remember. Transistors, the miracle of this world, what we're going to actually be building the processor out of after we learn all this boring stuff. Again, I'll come back to those. I'll show them in more detail. You're going to be working with rectifying diodes to keep current flowing in one direction. Again, pause, memorize. And then to regulate battery voltages, because you can't always find the voltages that you need just from straight batteries, we're going to use what is known as linear regulators. Again, pause, move on. I'm sorry, I have atrocious handwriting, but the words in there say in on the left, ground at the bottom, and out on the right. That little like three-prong upside down Christmas tree at the bottom is a symbol for ground. I'll go into that later because there's various types of ground that you should be aware of. The next thing is I want you to specifically remember the top left. That is for a single pole, single throw switch, or in other cases, it's the most simple on-off switch you have. It just simply puts a break in the circuit. I'm going to show you how those works with series and parallel circuits so I can get an idea across. So you need to memorize that. Then you have your battery, and then you have your integrated circuit, which may run into once or twice for generating clock signals or demonstrating a point. So these are just boxed with their pins conveniently arranged around to fit best in your schematic. Again, I'll go all over those extra components that I mentioned when we get there. But for now, resistor, LEDs, and the battery is what you need to memorize. In our next tutorial, I'm going to show you the differences between series and parallel circuits, as well as how to wire your multimeter into these, so I can show you that Ohm's law actually does work when you put it in practice. A lot of people tend to throw math out the window, but as I found out, if you do the math beforehand, it'll cause you a lot less headache later. This is just a kind of a shout out. If you guys have any suggestion for good video editing software for Linux, specifically Linux Mint, please let me know. Possibly give me a link to a tutorial and stuff, because these videos are horribly boring to make, and it would be a lot better if I could actually edit photos into these so it's less of a hassle to show you guys what's going on. As soon as I get a more stable camera mount, they also may be a little easier to follow. But for now, I hope you enjoy the videos, and see you next time.